All right, in homework 12.2, we are simplifying and stating excluded values. I'll do a couple of these. The first, I just guess I'll do number one. We have a linear term divided by a linear term, and when they're linear terms, if there's a binomial, we want to factor out any common factor. So this is 10 times 3k minus 2. 10 times 3k is 30, 10 times negative 2 is negative 20, divided by 90. And then once it's factored, this is multiplying by 10 and dividing by 90. We can divide both by 10. We can only do this once it's factored, or if we divide both the factors. So we get 3k minus 2 divided by 9k. Sorry, I lost the k here. After we simplify, we want to state any excluded values, and we really want to look at it before we simplified. Are there any values that make us divide by 0? We don't care at all about the numerator for excluded values, we're just looking at the denominator. So what we're really asking is there anywhere where 90k equals 0? And the answer is yes, of course. K equals 0 is an excluded value. So this is the simplified version. We usually put a comma and say k can't equal 0, right? Let's do a slightly more complicated one. Let's do something like number 5. Number 5, this is a quadratic. We can factor that. This is p minus 9 times p minus 9. Or we could put p minus 9 squared. Both of these are the same, divided by p minus 9. And we'll notice we can simplify one of the p minus 9. So this is multiplying by p minus 9 and divided by p minus 9. We can cancel it out. That cancels out one of the p minus 9s. And so we just get p minus 9. However, it's only p minus 9 when p does not equal 9. Because even though it looks like, hey, you can plug in 9 here. 9 minus 9 is 0. That's fine. That doesn't seem to be a problem. It wouldn't equal the original one. Because in the original one, when we plug in 9, we would get 0 over 0. And 0 divided by 0 does not equal 0. It's undefined. So whenever we get 0 over 0, it's not 0, it's undefined. And so when we simplify, I guess I should have put over p minus 9 here. When we simplify, we make sure that it still can't equal any of the excluded values. So it's p minus 9, but p can't equal 9. 9 is the excluded value. All right, let's do one more, maybe two more, I don't know. Let's look in the back. Oh, look, looks like we have a cubic. That's fun. Let's factor all of these. So if there's a numerator and a denominator, we need to factor all of them. The first thing I notice in the numerator is that they're all even numbers. So they have a common factor of 2. X squared minus 12x plus 35. In the denominator, not only are they all even coefficients, they all have an x, which is what's going to make this cubic a lot easier. Otherwise, we'd have to do long division or something. So 2x times x squared minus 10x plus 5. Now we can factor these binomials, these quadratics even more. This is 2 times, let me make sure I'm not off the screen here, 2 times x, we need to multiply to make 35 and add to be negative 12, x minus 7, x minus 5, 2x times, oh wait, something's going to be wrong here. I don't know why when I divided by this by 2, I said 25, I think, but I wrote 5. 2 times x minus 5 squared. X minus 5 times x minus 5 gives us x squared minus 10x. And now we look, is there anything we can cancel? Yes, we are multiplying by x minus 5 and dividing by x minus 5. Cancels out one of the x minus 5's in the denominator. Here, it's multiplying by 2 and dividing by 2. Cancels that out. And so what we end up with is x minus 7 divided by x times x minus 5. And we usually can, after we've simplified, we might want to think, hey, can we cancel out these x's? Did these x's cancel out? And the answer is no. Hell no. Do not do that. Here it's dividing by x. Here it's adding and subtracting. You can only cancel things out if they're in factored form. So if this was x times negative 7, we would cancel out the x's. But since it's x minus 7, this x is dividing both of these, and it doesn't go into the 7, so we can't divide it. I'm going to go ahead and multiply out just to simplify all the way, x squared minus 5x. We don't need to do this all the time, but I'm doing it here. And so this really ugly thing simplified all the way down to this, except there are three excluded values. I'm going to put x can't equal, this is equal to this as long as x is not equal to 5 and 0. Those are my excluded values. Notice even when I simplified here, I didn't cancel out anything that would have had more excluded values, but if I did, I would have to put the excluded values I canceled out also. I'd just like to point out one thing. Down at the bottom, there's a cubic that doesn't have a common factor. You have two choices when you're trying to factor this. You can either use an advanced factoring technique and factor out the common factors of both of these and then continue factoring, or you can use long division to try to factor this. Either way will work, but you do need to end up factoring it and canceling out this stuff. All right, good luck on the rest of your homework.